The following presentation was recorded at the NDS Public Conference in May 2022.
Hi everyone, my name is Otto Nyiro. I'm the director of NDS Competence Center at NNG, where we are focusing on innovative technologies around NDS. So it's mainly now NDS.Live. We are doing prototypes and started working also on projects with NDS.Live. Today I brought two demos. One of them is we consider it as a major achievement of the NDS.Live development from last year. So I will talk about it a little bit later, but it's basically we compared two NDS.Live module versions, and I will show you how what was the size reduction that we achieved last year with NDS.Live. And the second demo is the LiveLab demo, the LiveLab demonstration of our PaaS service. So the Live, as Fabian also introduced, the LiveLab, it is used for inspecting LiveLab data, LiveLab services, and also to visualize data, data layers. Right, so let's start with the NDS.Live size reduction. Last year on the NDS conference, I demonstrated how we can retrieve smart layer ties from the service, and this is actually a GET service. So this is easy to get smart layer ties by just requesting a special tile ID. As you can see, this is based on horizon, so we don't have any active route. And on the left side, you can see the data layers that we are fetching in the smart layer service. But the most important is today is the bottom right corner, the download counter. So you can see the data consumption of downloading these 3 tiles. It's in the downtown of Munich, so the quite dense network. And last year when I prepared this demo, we realized that, wow, the size of the smart layer package that we download, so these 4 data layers, it's quite high, higher than what we are using in NDS Classic. So in NDS Classic, we also have a solution for streaming tiles for ADAS applications. And so it is higher, it's definitely higher. On one reason, NDS.Live is providing self-contained tile. So what we expected that it will be a little bit bigger size-wise, but still we think it's higher than that is acceptable. So then after the last NDS conference, we started a discussion on a technical working groups, how we can optimize the size in NDS.Live. And now you can see that this is a new NDS.Live module version. It was released last year in September. We didn't change anything in the service, just we migrated to the new NDS.Live version. And then we immediately saw that, wow, the size, the data consumption is significantly lower. And so that's great. And but then let's see it in a comparison. So on the left-hand side, you can see the older NDS.Live module version. Just check the data consumption counter. On the right-hand side, we have the new module version. And then we made some analysis, some statistics, and just based on this simple route in Munich downtown, we achieved 38% reduction just by migrating to the new NDS.Live version. So I think that's already a great achievement. Now let's see it in a way that we are streaming, we are requesting a list of ties around the car position, around the horizon. And then what we see that we achieve the same size reduction ratio. So it's again 38%, just simulating this this MPP in a downtown area with a dense network. All in all, what we see that the size that we achieved with this new NDS.Live module version, it's still slightly higher than the NDS classic ties. But when it comes to service, when we start, let's say, streaming ties and we compare it, it's now already on par. Because in NDS Classic, the ties are not self-contained. That means there are references to the adjacent or any other ties in the area. So it usually happened that we had to download further ties for the horizon that we never used actually, but just because of the external relation in the ties. So I think we are good now. At least we are on par with NDS Classic on data consumption when it comes to smart layer tile services. But the main benefit of using NDS.Live that we have more flexibility in working on future map use cases, and this is the smart layer path service. We are fetching the same data layers, so road geometry, characteristics, and rules, because these are the data layers that are required for ISA use case. But we don't need the rest of the ties, only the map pass around the horizon. So this is actually one of the benefits of using NDS.Live. So we have both flexibility in fetching data, but still you can see on the screen that we are consuming data. It's significantly less than downloading ties. But still, when it comes to annual data consumption, it can be significant. So then we applied the same smart layer path service to the new NDS.Live module version. So we migrated the whole service and didn't change anything in the settings. So same routes, same data layers, but with the new module version. And what we saw that this size reduction with the new module version is applicable for the smart layer path as well. Let's see it in a comparison. So on the left-hand side, we have first pass is 6 kilobyte. On the right-hand side, it's just 4 kilobyte. The difference is not that big. But still, if we are using this technology, the smart layer path service for a ISA service, where we need to maintain it for 14 years, and the data plan needs to be paid on annual basis, it can be still significant, I would say, 20, 30 megabyte per year. However, with migrating to the new NDS.Live module version, we can achieve also significant size reduction. So comparing to let's say 30 megabyte per year, now we need to consume only 20 megabyte per year just to get ISA into the car. This is a reference route. It's an ISA reference route. Based on the specification, the length of the route is just half, because we use it for simulating the route with the driven speed. So this is one consecutive route where the start and the end point is the same, and it goes to urban streets, urban main roads, urban streets, rural roads, and also motorways, expressways, in a ratio that is defined by the ISA regulation. And then I made some simulation on this route with wide corridor, so 3x3 ties around the car. Then the middle option is just one tile width, and the third one is the path only. And what we can see that we can reach almost the same level of data consumption reduction. So it's around 30%, and it also helps us to estimate the expected required data plan for ISA use case. Right. So now the next demo is about the LiveLab implementation. For that, I will show you in LiveLab how this smart layer path service can be inspected and visualized. It's mainly for, let's say, to show the interoperability of our service. I hope I can somehow. So let me just go back to the beginning of the video. And I will show you 3 different scenarios how we can get paths. So when I start the video, you can see that we don't have any map at all. Everything is in the cloud, and we get it on request. The first request is based on vehicle pose. So we need to upload the first, let's say, first 3 position of the car with the heading information. For that, we already have a standardized application service interface that's called NDS.Live vehicle pose. So we use that NDS.Live service interface that retrieves the map matched position of the car, also with the heading information. And based on that map matched position, we do a horizon calculation in the cloud, and then fetching the map path for the horizon. Now, the second option how we can get horizon is when we are approaching to the end of the tile. And in that case, we don't need to request a new map matching from the cloud service, because we already have a map match position. So based on that, we just know that what is the last segment of the path. And then based on that segment, we can request the next path. Here we go. The LiveLab implementation is partly based on that concept. And the third option is what happens if we deviate from the path. For that, we use these stubs. Without stubs, we need to request a new vehicle pose, a new map match. It takes time. So it might happen that for certain seconds, we won't have any speed limit. But with the stubs, we can provide seamless ISA data. So if we deviate from the path and just enter the stubs, then another request is sent to the cloud that we need a new path based on the stubs. So I will use this concept to show the LiveLab implementation. But before that, let me show you the product that we are developing based on that Smart Layer Path service. So it was also mentioned by Martin, the chairman, that that you are looking for seeing products that are being leveraging using this NDS.Live technology. At NNG, we call it as an iGo.Ahead product. It's based on a Smart Layer Path service. For that, we need the data layers as a data publishing service. In this case, the data layers are published by here, and they are proxied to the NNG cloud. Then on the client side, we have the positioning, and the vehicle pose is then sent from the client to the NNG service. So this is actually the NDS.Live vehicle pose application service interface. And the magic is done in the NNG cloud, where we already have the published the NDS.Live data layers from here. And we do the map matching there based on the road layer and some other information. And then the horizon is also calculated there. And then we are fetching. So we exactly know the use case where we don't need the ADAS layer, just certain other layers, and then fetching only the path. And then because the ECU architecture requires another protocol, so we encode the Smart Layer path to that protocol. Further on, we are also planning to evaluate the SAM-IP transport protocol, but that's applicable for the HD lanes and not for the SD layers. If you would like to get more information on this product, you can check it on the webinar. Now, let's go to the LiveLab implementation. So this is a tool provided by the NDS Association. And that's a great tool for the NDS.Live developers. They can easily inspect the service, what is retrieved, and there is a map viewer to visualize the retrieved data layers. We need to do some Python magic, some Python scripts. For that, some of them are already available that we can reuse. They are in the community library or someone else. We also reused some of the community plugins for that, but the rest was developed by, the script was written by NNG. For this visualization of the path and how we can retrieve, let's say that's 200 rows in a Python script. And now the video. So it was. So I pre-recorded it in Hungary before when I prepared for this demo, because this LiveLab requires a developer PC or developer laptop. It turned out, so it doesn't run smooth on my office laptop. Yeah, well, it is designed for developers, and they don't have any problems with the performance. So so how we can visualize, how we can show the whole Smart Layer path in LiveLab. For that, we preloaded 2 tiles. This is in Frankfurt. The preloaded tiles can be NDS Live data layers or NDS classic tiles as well. we saw it in from Fabian's presentation that we already have a solution where we can reference NDS Classic ties and NDS.Live data layers. The reason for I had to preload these two ties is because we need to get the map match position and the heading information for the service, because the online map matching, I mean not the online, but the vehicle pose is not yet implemented in this LiveLab. Only the how we can request smartly a pass based on already map matched information. For that, I picked this road segment, and then I select this part, or I mean this end of the road segment, indicating the heading direction, and then the magic happens there. So that was the request to the service. First, I need to get a horizon based on that map matched position and heading information, and let me please fetch me the required path and also the stops. And now at least you can see it on the screen how the algorithm works. So how we fetching the stops. It can be configurable in the cloud. So how what is the optimal length of the stops, and what is the length of the main path as well. So in this case, the path is calculated only till end of the tile. Then and you can also see the visualization of the speed limit information. This is coming from the community script of the LiveLab. Then what you can also see here is not all the adjacent roads are selected in the stops, because this is based on topological selection. So if we cannot make any turn on that route, then we simply don't add it as a stops. So that's where we can also optimize the solution. And now selecting a stub in the LiveLab there, and then the new path is immediately retrieved. Again, you can see how the path looks like on a offline database. And then now we are leaving the safe zone and retrieving the path outside of the offline ties. This is how it looks like. And then I'm again selecting a stub, simulating that I'm deviating from the main path, from the magenta color, and then a new path is immediately retrieved. It's again till the end of the tile, and then I request a new path, and so on and so on. So this is the way how our engineers, the NDS.Live developers, can easily inspect the service and also what is retrieved, what are the data layers, and what is the content, the properties, the attributes of the data layers. This can be also a tool that we provide along the product itself, so that prove the interoperability of our solution, so everyone can easily inspect this NDS.Live service. And this is now just to show that how we can inspect the attributes of the path data. Okay, so that was my presentation, the two demos. Thank you.
Thank you for watching. Visit our website for news on NDS at nds-association.org.